Okay, let's get into it. Number 10, the Andromeda Collision. Right now, tonight, there is a galaxy falling toward us. Not drifting, not idling, falling. It's called Andromeda, and it holds something like 1,000,000,000,000 stars, and it is closing the gap between us at about 110 kilometers every single second. You can actually see it with your own eyes if you know where to look. A faint smudge of light in the autumn sky. That smudge is the most distant thing a human can see without a telescope. And it's headed straight for home. For decades, the story went like this. In roughly 4.5 billion years, Andromeda and our Milky Way slam into each other. The two great spirals tear each other apart, fling out long streamers of stars, and eventually settle down together into one giant elliptical blob of a galaxy. Astronomers even gave the merged thing a nickname, Milkomeda, half Milky Way, half Andromeda. A cosmic marriage written in the math of gravity. And here's the strange, quietly beautiful part. Even in a full head-on collision, almost nothing actually hits anything. Galaxies look solid from a distance, all that glowing light packed together. But the space between stars is so vast that when two galaxies merge, individual stars sail right past each other, untouched, like two swarms of fireflies drifting through one another in the dark. Our sun, if it still existed, would probably never feel a thing. The sky would change. The nights would fill with a second river of stars. But the collision itself would be silent. But here's the thing. We're no longer even sure it's going to happen. In 2025, astronomers took the newest data from the Gaia spacecraft and the Hubble telescope and ran the numbers again, more carefully than anyone had before. And the guaranteed collision suddenly wasn't guaranteed at all. Their models gave it something closer to a coin flip, roughly a 50-50 chance of the two galaxies actually colliding within the next 10 billion years. And even if they do meet, it might not be a crash. It might be a sideswipe, a glancing blow, a near miss stretched across millions of years. It turns out a third galaxy, a smaller one called the Large Magellanic Cloud, has just enough gravitational pull to nudge our whole galaxy slightly off course. Enough to turn a certain collision into a maybe. So the most famous cosmic catastrophe in all of popular science, the one in every documentary, the one with the gorgeous simulations, might be a story we told ourselves a little too confidently. The galaxy is still falling toward us. We just don't know anymore if it'll hit. And somehow, that's more unsettling than certainty ever was. Number 9. Gliese 710. There's a star you've never heard of, sitting about 62 light-years away in the constellation Serpens, and it is coming for us. Slowly, patiently, on a path that will bring it closer to our sun than any star we know of for millions of years in either direction. Its name is Gliese 710. It's a small orange dwarf, smaller and dimmer than our sun, nothing special to look at. But its trajectory is the thing. When astronomers fed the precise measurements from the Gaia mission into their models, they found that in about 1.3 million years, Gliese 710 is going to pass through the outer edge of our solar system. Not near it. Through it. Now, it's not going to hit a planet. It's not going to hit the sun. When they say it passes through the solar system, they mean it plows into a region most people don't even know exists. The Oort cloud. Picture a vast spherical shell of icy debris, comets, frozen leftovers from the birth of the planets, wrapped around the entire solar system like the skin of an enormous invisible balloon, stretching out trillions of kilometers in every direction. That's the true edge of the sun's domain. And Gliese 710 is going to sail right into it. The best estimates give it something like an 86% chance of passing directly through that cloud of comets. And when a star's gravity moves through a swarm of loosely held ice, it stirs the pot. It grabs comets that have sat quietly in the deep freeze for 4 billion years and flicks them loose. Some get thrown out into interstellar space, and some get thrown inward, down toward the sun, down toward the planets, down toward us. But here's the thing. The danger isn't the star. The star will pass and be gone. The danger is what it leaves behind. A slow rain of comets that could last for 1 million years afterward. One estimate suggests the sky could fill with something like 10 comets, bright enough to see with the naked eye, every single year, for ages. 10 comets a year. A sky that never stops burning with visitors. And in all that traffic, the odds that one of them eventually finds the Earth quietly climb. It's a threat with a countdown longer than our entire species has existed. A star drifting closer in the dark, 1 patient meter at a time, aiming not a bullet, but a shotgun blast of ice at a target it will never live to see it hit. Number 8. The Magnetar Flare. On the 27th of December, 2004, something reached across 50,000 light-years of empty space and touched the Earth's atmosphere, and it did it in 0.2 of a second. The source was a star called SGR 1806-20. It's a magnetar, which is a particular kind of dead star, a neutron star, but one wound up with the most powerful magnetic field known to exist anywhere in the universe. We're talking a magnetic field maybe 1,000 trillion times stronger than the Earth's. If one of these things drifted to within a few 100,000 kilometers of you, the magnetic field alone would rip apart the atoms in your body. Not the radiation, the magnetism. And this particular magnetar had a bad day. Something in its crust cracked and slipped, a starquake, and in a single flash it released a giant flare. Now, I want you to really sit with the numbers here, because they don't feel real. In 0.2 of a second, that flare released more energy than our sun puts out in about 250,000 years. 250,000 years of sunshine, released in less time than it takes you to blink. That energy crossed 50,000 light years, nearly the entire width of our galaxy. And when it arrived, it was still strong enough to slam into the top of Earth's atmosphere and ionize it. It changed the electrical properties of our upper atmosphere at an altitude of about 60 kilometers by a staggering amount. Detectors that were pointed at completely different things got blinded. Satellites felt it. It bounced off the moon, a star on the far side of the galaxy, and it rang our planet like a bell. But here's the thing. That object is roughly 20 kilometers across. 20 kilometers? You could drive across it in the time it takes to get through a mid-sized city. Something the size of a town, 50,000 light years away, reached out and physically disturbed our world. And so, of course, the obvious question hangs in the air. What if one were close? Not 50,000 light years. What if a magnetar flared a few dozen light years from here? The honest answer is that it would strip our ozone, flood us with radiation, and it would not be a good day to be alive on the surface of the Earth. We don't know of any magnetar close enough to do that. But the universe has already shown us, from across the entire galaxy, exactly what these tiny dead stars are capable of. No light, no warning, just 0.2 of a second, and the sky flinches. Number 7. Rogue black holes. Here's a thought I'd like to ruin your evening with. Not every black hole sits politely at the center of a galaxy. Some of them wander, alone, silent, through the dark between the stars, and you would never, ever see one coming. For a long time, this was just a suspicion. We knew, in theory, that when big stars die and collapse, they should leave behind black holes, and that many of those should end up drifting through the galaxy on their own, with no companion star to give them away. The Milky Way should be full of them. Some estimates say hundreds of millions of these lone black holes roaming our galaxy right now. But suspecting they're out there and actually catching one are two very different things. Because a solitary black hole gives off no light. It's not eating anything, so there's no glowing disk of superheated gas. It is, quite literally, a moving piece of nothing. So how do you find something that's invisible by definition? You wait for it to pass in front of a star. When a black hole drifts between us and a more distant star, its gravity bends and warps that starlight, a trick called gravitational microlensing. And for a while the background star appears to brighten and shift ever so slightly. It's the shadow of a thing revealing itself only by how it distorts the light behind it. And in 2022, after years of painstaking work, astronomers announced they'd done it. Using the microlensing surveys and then the sharp eyes of the Hubble telescope, they confirmed the first isolated, wandering black hole ever found. It sits about 5,000 light-years away, weighs around 7 times the mass of our Sun, and it's coasting through the galaxy at about 50 kilometers per second. It took them roughly 10 years of watching a single warped point of light to be sure of it. But here's the thing. That's one. One that happened, by pure chance, to line up with a star behind it so we could catch its silhouette. Every other one out there, the hundreds of millions of them, is still completely invisible. There could be one crossing the empty gulf between us and the nearest stars at this very moment, and we would have no way to know until its gravity began, very gently, to bend the light of the constellations. Now, is one likely to come and swallow the solar system? No. Space is unimaginably big, and these things are spread thin. The odds are tiny. I want to be honest about that. But tiny is not the same as zero, and there's a specific flavor of dread reserved for a danger that is completely silent, completely dark, and completely undetectable until it's nearly on top of you. Every other threat gives you a warning. A flare, a flash, a star growing brighter. A rogue black hole gives you nothing at all. It's out there in the dark right now. You just can't see it. That's the whole point. Number 6, the death of the sun. Everything on this list so far has been a maybe, a could, a distant if. This one is different. This one is a will. Because the star that gives us everything, every sunrise, every warm afternoon, every crop that's ever grown, is going to die. And it's going to take the Earth with it. Our sun is about halfway through its life. For roughly 5 billion more years, it'll keep burning hydrogen in its core, more or less the way it does now. But hydrogen runs out. And when it does, the sun doesn't just quietly switch off. It does something far more dramatic. The core contracts and heats up, and the outer layers respond by swelling enormously. The sun becomes a red giant. It will bloat to more than 200 times its current size, growing so large that it swallows Mercury, then Venus, and reaches out toward the orbit of the Earth itself. Whether it physically engulfs our planet is genuinely still up for debate. As the sun swells, it also loses mass, which loosens its grip and lets the planets drift to wider orbits, so Earth might just barely escape being swallowed. But it almost doesn't matter, because long before the sun becomes a red giant, we're already finished. Here's the part that catches people off guard. The sun is slowly getting brighter as it ages, a little more luminous every 100 million years, and in only about 1 billion years, it will be bright enough to boil away Earth's oceans. Not 5 billion. 1. The seas evaporate, the atmosphere is stripped, and our blue world becomes a scorched, dry rock, a dead planet orbiting a sun that hasn't even started its final act yet. Life on Earth has an expiration date, and it comes billions of years before the fireworks. Then, eventually, the red giant phase ends. The sun sheds its bloated outer layers into space in a gorgeous glowing shell, a planetary nebula, and what's left of the core collapses down into a white dwarf. An object about half the mass of the sun, crushed into a ball smaller than the Earth. It will sit there, slowly cooling, for longer than the current age of the universe. A dim ember where a star used to be, orbited by the burnt-out cinders of the worlds it once warmed. That's the future of home. Not a dramatic explosion, a slow swelling, a boiling, a dimming. The star we owe our entire existence to is also, on a long enough timeline, the thing that erases us. And there is nothing anyone can ever do to stop it. It's the one appointment the Earth cannot miss. Number 5. The Awakening of Sagittarius, a star. 26,000 light-years from here, at the very center of our galaxy, there is a monster. It weighs about 4 million times as much as the Sun. It is a supermassive black hole, and its name is Sagittarius A star. And right now, thankfully, it is quiet. Sleeping. Feeding only in small, gentle sips. But it has not always been quiet. And there is a scar in the sky to prove it. If you could see our galaxy in gamma rays, the most energetic light there is, you would notice something enormous hanging above and below it. 2 gigantic bubbles of superheated plasma, ballooning out from the galactic center, each one stretching about 30,000 light-years from top to bottom. They're called the Fermi bubbles, and for years nobody was sure what made them. Now, we have a very good idea. They are the leftover blast wave from the last time our sleeping monster woke up. The evidence points to a colossal eruption around 3.5 million years ago. Something, most likely a big cloud of gas, fell into Sagittarius A star, and the black hole roared to life. It became what astronomers call an active galactic nucleus, blasting out cones of radiation and plasma straight up and down out of the plane of the galaxy. That radiation punched so far out into space that it lit up streams of gas well beyond the Milky Way entirely, and it inflated those 2 vast bubbles that still tower over us today. But here's the thing. 3.5 million years ago is nothing. In cosmic time, that's this morning. 3.5 million years ago, our own ancestors were already walking upright on the plains of Africa, which means something remarkable and eerie. There may have been early humans, or something very close to them, who looked up at a galaxy with a glowing, violently active heart. A core lit up like a beacon. They wouldn't have understood it. But they might have seen it, and a black hole that erupted once can erupt again. All it takes is another cloud of gas, another wandering star, another meal drifting too close, and Sagittarius A star wakes back up. If it flared today, the worst of it would be aimed out of the galactic plane, and at our safe distance of 26,000 light-years, it probably wouldn't end life on Earth. Probably. But the heart of our galaxy would blaze, and the night sky would carry a new and terrible light. The monster is sleeping. It has slept before, and it does not sleep forever. Number 4. Betelgeuse. Go outside on a winter night and find Orion, the hunter, the easiest constellation in the sky to spot, with those 3 stars in a neat row for his belt. Now look up to his shoulder, to that big star with the distinctly reddish-orange tint. That's Betelgeuse, and that star is going to explode. Betelgeuse is a red supergiant, and it is genuinely enormous. If you dropped it where our sun is, it would swallow the Earth, Mars, and reach out past the orbit of Jupiter. It's the kind of star that lives fast and dies young. It's only a few million years old, a blink compared to our sun, but it's already burned through most of its fuel and is staggering toward the end. When a star this big runs out of fuel, its core collapses in a fraction of a second, and it detonates as a supernova, one of the most violent events in the entire universe. And a few years ago, it looked like the show might be starting. In late 2019, Betelgeuse began to dim, and it kept dimming, dropping to less than half its normal brightness by February of 2020. People got excited. Was this it? Was the old star finally going? Astronomers watched it obsessively, but it turned out to be a false alarm. The star had coughed out a huge cloud of dust that temporarily blocked its light. Not a death rattle, just a burp. The Great Dimming, they called it, and eventually Betelgeuse brightened back up. So when will it actually blow? Nobody knows. And I mean that literally. The estimates are all over the map. Some say it could happen within a few tens of thousands of years. One paper suggested it might be as soon as within decades, and others push it out past 1,000,000 years. On a human timescale, it's basically a cosmic slot machine, and we can't read the reels. When it does go, it'll be spectacular and completely harmless to us. At around 500 to 600 light years away, it's far too distant to hurt the Earth. A supernova would need to be within roughly 50 light years to really threaten us. Instead, Betelgeuse will flare up to be as bright as a crescent moon, crushed into a single point. Bright enough to see in broad daylight. Bright enough to cast shadows at night. For weeks. But here's the thing, and this one always gets me. Betelgeuse is around 600 light years away. That means the light we see from it tonight left the star 600 years ago. So when you look up at that orange dot on Orion's shoulder, you are not seeing Betelgeuse as it is. You're seeing it as it was 6 centuries ago, which means it is entirely possible that Betelgeuse has already exploded, that it is, right now, an expanding cloud of debris and a dead core, and the light of its death is simply still on its way to us, crossing the dark, and hasn't arrived yet. You might be looking at a ghost, a star that no longer exists, still shining in our sky, waiting for the news to reach us. Number 3, Proton Decay. Everything I've talked about so far destroys things. It blows up a star, swallows a planet, floods a galaxy with radiation. But the stuff being destroyed, the atoms, the matter itself, survives. It gets scattered, transformed, but it's still there. This next one is different. This one doesn't destroy objects. It destroys the thing objects are made of. It erases matter itself. Let me back up. Everything you have ever seen or touched, this planet, your own body, every star in the sky, is built out of atoms, and at the heart of every atom is a nucleus made of protons and neutrons. The proton is one of the fundamental building blocks of reality, and for the longest time, we assumed it was completely, perfectly stable, eternal. A proton created in the first moments of the Big Bang would simply exist forever. But some of our deepest theories in physics, the ones that try to unify all the forces of nature into a single elegant framework, the so-called grand unified theories, quietly predict something disturbing. They predict that the proton is not eternal after all, that given enough time, a proton will simply decay, fall apart, dissolve into lighter particles and a puff of radiation, and be gone. And if protons can decay, then eventually, over time scales that make your head hurt, all the ordinary matter in the universe unravels. Every atom, everywhere, gone. So physicists went looking. In Japan, deep under a mountain, there's an experiment called Super Kamiokande, a colossal tank holding 50,000 tons of ultra-pure water, watched by thousands of sensitive light detectors. The idea is simple and beautiful. If you gather enough protons in one place and watch them closely enough for long enough, you should eventually catch one in the act of dying. And with that much water, you're watching an almost unimaginable number of protons all at once. They've been watching since 1996. Nearly 30 years. And in all that time, they have seen exactly 0 protons decay. 0. Now that sounds like good news. And in a way it is. It means if the proton does decay, it does so incredibly rarely. That non-detection sets a floor on the proton's lifetime of more than 10 to the power of 34 years. Let me try to make that number real, because it's hopeless. The universe is about 14 billion years old. The proton's lifetime is at least 10,000 trillion times longer than the entire current age of the universe. If you sat and stared at a single proton, you would wait, on average, far longer than the universe has any right to exist before you saw it die. But here's the thing. Ruling it out entirely might be even weirder than confirming it, because those non-detections have already killed off the simplest versions of the grand unified theories, the ones that predicted protons should decay a bit faster than they apparently do. So physics is caught in a strange bind. Either the proton really does decay, and all matter in the universe is very, very slowly on death row, or the proton is truly immortal, and some of our most cherished, most elegant ideas about how the universe works are simply wrong. There's no comfortable answer. Either substance itself has an expiration date, or reality is stranger than our best theories can explain. And in the far, far future, long after the last star has burned out, that quiet, patient dissolving may be the last thing that ever happens. Matter, gently forgetting how to exist. Number 2, the Big Crunch. Everything in the universe is flying apart. Ever since the Big Bang, space itself has been expanding, carrying the galaxies away from each other, and for the last several billion years that expansion has actually been speeding up. Something is pushing the cosmos apart, faster and faster, and we gave that something a name even though we barely understand it. We call it dark energy. And for a long time, we thought it meant the universe had only one possible ending: a cold, empty, endless expansion into the dark. But what if it reversed? What if the expansion slowed, stopped, and then began to run backwards? That is the Big Crunch. It's the Big Bang played in reverse. Instead of everything flying apart, everything falls back together. Galaxies that spent 100 billion years drifting away suddenly begin to approach, then to rush. The sky, which had gone dark and empty, fills up again as galaxies pile back in on each other. Space itself contracts. The temperature climbs. Everything, every star, every planet, every atom that survived gets crushed together, hotter and denser and tighter, until the entire universe collapses back into a single, infinitely dense point, the mirror image of the moment it was born. For years, most scientists thought this was off the table. The whole point of dark energy was that it was pushing everything apart, and if it stayed constant forever, a big crunch simply couldn't happen. The universe would expand and cool and fade, and that was that. But here's the thing. In the last couple of years, that certainty has quietly cracked. There's a project called DESI, the Dark Energy Spectroscopic Instrument, and it's been building the largest three-dimensional map of the universe ever made, measuring how galaxies have spread apart across some 11 billion years of cosmic history. And when the results came in, starting in 2024, they contained a hint that nobody was quite prepared for. Dark energy might not be constant after all. It might be changing, weakening. The thing that's been pushing the universe apart may be getting tired. And if dark energy keeps weakening, if it fades and then flips from pushing to pulling, then the expansion can stop and reverse. And the big crunch, the ending we thought we'd ruled out, comes roaring back as a real possibility. Some estimates from this new data suggest the collapse could begin in something like 20 billion years, which, for the entire universe, is soon. I want to be careful here, because this is cutting edge and not settled. The evidence is a hint, not a proof, and plenty of scientists still expect the cold, endless expansion instead. But that's almost the most unsettling part. We are alive at the exact moment when we've realized we genuinely do not know how the universe ends. It could fade out slowly in the cold and the dark, or it could come crashing back in on itself, gathering everything that ever existed into one final point of unimaginable heat and pressure. Total annihilation, not with a whimper, but by putting the entire universe back into the box it came from. Number 1. Colliding universes. Everything up to now, every star, every black hole, the death of the sun, even the collapse of the whole universe. All of it happens inside our universe, inside the space and time we know. This last one comes from outside, from a direction you can't point to, and it could erase everything, instantly, without a single warning. To understand it, you have to let go of an assumption you've probably never even noticed you were making, that our universe is everything there is, that the universe and reality are the same word. Some of the most serious theoretical physicists alive don't think that's true. In their picture, our entire universe, all of space, everything in it, all 14 billion years of it, is something like a vast, thin sheet, a membrane. They actually call it a brain, short for membrane. And that brain floats in a much larger, higher dimensional space. And ours is not the only one. There can be other brains, other universes, floating out there in that greater space, parallel to ours, unreachably close, separated from us by a distance in a dimension we cannot see or move through. This isn't just idle daydreaming. Back in 2001, a group of physicists, Justin Corey, Bert Overath, Paul Steinhardt, and Neil Turok, proposed a genuinely serious model built on exactly this idea. They called it the ekpyrotic universe, from an ancient Greek word meaning conflagration, a burning up. And in their model, they suggested something breathtaking, that our Big Bang, the birth of everything, the fireball that started it all, wasn't the beginning of existence. It was a collision. Two brains, two universes, drifting toward each other across that hidden dimension, meeting and touching. And where they touched, all their motion turned into heat and light and matter in an instant. A universe ignited. Now follow that thought all the way down, because here's the thing. If a brain collision can start a universe, then what happens to a universe that already exists when the brains collide again? In the fuller version of this idea, the cyclic model, this has happened before, many times, maybe an infinite number of times. Two brains collide and fire off a Big Bang. The new universe expands, forms galaxies and stars, and sometimes curious creatures who look up and wonder where they came from. Then, over unfathomable stretches of time, the brains slowly drift back toward each other, and they collide again. And everything that universe ever built is wiped clean in the flash of the next Big Bang, so that the next cycle can begin. If that's true, then our universe isn't a one-time event. It's one frame in an endless film. One breath in and out of a cosmos that has been being born and erased forever, with no first beginning and no final end. And somewhere out there, in a direction we cannot perceive, another brain may be drifting toward ours right now. We would never see it coming. There would be no warning star, no dimming light, no slow collapse, just a touch, in a dimension we can't point to, and then everything we've ever known, rewritten in an instant of fire. I have to be honest with you. This is the most speculative thing on this entire list. There's no proof. It sits right at the frontier of theoretical physics, and plenty of scientists think the truth is something else entirely. But that's exactly why I wanted to end here. Because it forces the biggest question of all. We spend our lives assuming that reality is the stage everything plays out on, solid, permanent, the one thing you can count on. But maybe reality itself is just a surface, a thin membrane humming in the dark, next to others we'll never touch. And maybe the story of everything is not one grand tale with a beginning and an end, but a fire that has always been burning, going out and catching again, forever. We are a spark inside one frame of that fire, alive, right now, looking up and wondering. And the fact that we get to wonder at all, in the tiny window between one flash and the next, might be the most dangerous and precious thing in the whole universe. Thank you for watching and sticking till the end. We've got plenty more videos coming in the future. Hit that subscribe button so you don't miss them. See you in the next one.